Hello and welcome all. Exciting stuff today. We're going to be doing two lessons, 3.7 and 3.8. So, hopefully we're excited as is, as is proper. We're going to get right to it. Again, this is just solving quadratic. It's more of the same stuff. Realistically, we're just going to be completing the square, solving quadratic equations, except now we're going to have to do the little bit of extra work where we have to write the equations ourselves. So we're going to write the equation by, of course, reading this problem and putting together some equations. So we'll get started on that. So when two consecutive numbers are squared and the squares are added, their sum is 421. What are the possible numbers? So this is again very straightforward. So let the first number be x. So the second number is x plus 1, or you can just say let the consecutive numbers be x comma x plus 1. It doesn't matter really how you straight phrase that, so this would probably, I think, be a little bit better. But the two numbers are x and x plus 1. Consecutive, as we know, means one after the other, so like 2 and 3, or like 16 and 17, or something like that. In this case, we could probably just do like some kind of a guess and check. So if you want the sum to be 421, I would guess 16 and 17. And that's 540, so probably like 14 and 15 maybe. So 14 squared plus 15 squared is 421. I have solved this question, but obviously that's going to get you like a half a mark if you just like do a bunch of guess and check work. We have to use algebra to solve this in a dignified manner, if you will. But it's always good to know our answer from the beginning, just so we know that once we do get the answer, we know that we're right. So here, let's see, x squared plus x plus 1 squared is going to be equal to 421. That's what we're given. We're saying if you take both the numbers, you square them, and then you add those squares, you get 421. So let's expand this. X squared plus 2x plus 1 421, and then I am going to now try and solve this equation, and doing so I'm going to factor out it. So step 1, again, factor out at 2, x squared plus x, move this one to the other side, 420. Let's go. Step 1.5 is dividing both by 2 so that I get x squared plus x equals 210. And now step 2 is, as usual, finding that magic number. So I take this term here, which is a 1. I divide it by 2, and then I square that, which ends up being 1 over 4. So I get x squared plus x plus 1 over 4 minus 1 over 4 equals 210. X squared plus x plus 1 over 4 equals 210 minus 1 over 4. Plus 1 over 4 because I moved this to the other side. And I will combine these three terms to give me x plus half squared. Again, how I'm getting this half is, again, you take the square root of this. You can take half of whatever this number is, or you can refer back to step 2 and see that we took a half there. That's kind of how we got this half here. And this, of course, has to be common denominator. So this is 841 divided by 4. 841 looks very suspiciously non-rootable. It is rootable, so I will take the square root of both sides. X plus half equals, so plus or minus 29 divided by 2. Again, take the square root of the top and then take the square root of the bottom, and hopefully we're seeing that we get this. And so I'll break that up into two different parts. I say x equals to 29 over 2 plus a half, or x equals to negative 29 over 2 plus half. So here x equals to, it looks like 15, or x equals to negative 14. Just that. Oops, I made a little bit of a mistake here because I moved the plus half to the other side. It should really be a minus half. So this is actually positive 14 or negative 15, which actually makes sense because if you now look, and therefore the two numbers are, you could either go 14 and 14 plus 1, which is 15, or you could also have negative 15 and negative 15 plus 1, which is negative 14. So there's two possible solutions. Don't put brackets. If you put brackets, those look like coordinates. We're going to say the two numbers are 14 and 15, or negative 15 and negative 14, because both of those are technically consecutive numbers, and both of them, if you square and add those squares, you will get 421. So both answers are okay. Both answers work, and that's what we got at the beginning. Well, we got one of them at least. And here's the key. This is why you don't directly take the guess and check method, because you would have completely missed out on this answer. And that's why it's important. Well, maybe you would have thought about that. I guess I'm not smart enough to think that far ahead, and that's why doing algebra is important. Because we did get both the answers here, so we will get full marks for this question now. Okay, landscaper wishes to plant a boundary of tulips within a rectangular garden with dimension. I'm already asleep. Oh my god. Okay, dimensions 18 by 12. Okay, that's all that I'm worried about. To obtain a pleasing look, the tulip border should be half the area of the garden. Okay. So this is, hopefully we've done questions like this in grade 10. This is a very famous, very regular grade 10 question. You kind of have our boundary here. This entire thing is, let's say, 18. This entire thing is 12. And then we're going to have a boundary. So we're going to draw this dotted boundary. And this boundary has the same width. So here's what we're going to call a W for width. This is a W. This is a W, and this is also a W. And okay, so the tulip border, which I'm now going to shade. This is the entire border. Right? This area, the shaded area, has to be half the area of the garden. So the garden is, of course, the total area. So we're asked to find how wide the border should be, or how wide W is. And first of all, we can immediately say that the area of garden entirely is 18 times 12, right? That's the length times the width. 18 times 12 is 180 plus 36 is 216. Meters squared. So half the area of the garden is 216 divided by 2, which is 108 meters squared. So I know what the tulip border area should be. We want it to be 108 meters squared. Okay, so let's find, what exactly is the area of that tulip border? And this becomes kind of interesting. How do you really find the shaded area? The best way to do, the kind of border is always to take the area of the entire garden, which is here, take the entire area and kind of subtract it by the polka dot that's not really, this is a polka dot area. That's not really polka dots either. You know what I mean, the dotted area that I've just now dotting this area basically. This rectangle area, if I subtract that from the area of the total garden, I'll get the area of the border. So let's find that. So area of border equals area of big rectangle minus area of small rectangle. So hopefully everybody's with me so far. Area of big rectangle we know is already 18 times 12. But what is the area of the small rectangle? To find that, we have to find the length and width of the small rectangle. The length of the small rectangle here is 18 minus a W and minus another W. So let's see that again. So we're trying to find, we're trying to find this length over here, the small rectangle length over here. And we can see here that this entire big length is 18. And from that, we subtract a W minus W, and you take away another W, and we're left with the area, or the length really, that we want to find. So the area of the small rectangle is 18 minus 2W. That is the length times the width of that. And similarly, this entire thing is 12. I subtract a W, I subtract another W, I'm left with the width of the smaller rectangle. So 12 minus 2W. And here now we have our area of border, which is actually 216 minus 216 times minus 36W minus 24W plus 4W squared. Open the bracket. Before that, I will simplify inside. So 36 minus 24 is 60W plus 4W squared. And now I get 216 minus 216 plus 60W minus 4W squared, which is actually equal to negative 4W squared plus 60W. And this is a simplified expression for the area of border. But now I do know that my area of... Zoom out. Oh, save. Close. Oh, I have no space. Where was I? 60W. This is a simplified expression for my area of the border. And now, but I know my area of border, which is negative 4W squared plus 60W, has to be equal to 108, as established before, because that is half the area of the garden. I know this might be a bit complicated looking the first time you see it, but in all honesty, in like a test, you'll be given a very similar question, and as soon as you know kind of the trick about how to find the area of the smaller rectangle, that's the only like realistically complicated part. The rest of it is fairly straightforward, so to speak. But again, we have a simplified quadratic expression. We just have to find the, we have to solve it basically for W. And again, I'm going to use my usual thing. Step 1 is factor out a negative 4. Step 1.5 or 1.5 is divide both sides by negative 4. So I get W squared minus 15W equals, this is 27, negative 27. And if I look at this, 3 and 9 and 3 are two numbers that multiply to 27. They don't add to 15. So it looks like I'm going to have to do this the hard way, which is again, step 2 would be, take this number, negative 15, divide by 2, and, take the square root of that is 225 divided by 4, add and subtract, plus 225 divided by 4 minus 225 divided by 4 equals negative 27. Move this to the side, group this, and we know that if we group this, in fact, what we're going to get is this 15 over 2. So W minus 15 over 2 squared equals negative 27 plus 225 divided by 4. So take a common denominator here, which is 4. So w minus 15 over 2 squared equals 27 over negative 27 times 4 is 108 plus 225 is 117 over 4, right? And now, okay, so how correct to one decimal place. So again, here we're going to take the square root of both sides. We're going to, again, find that, we're going to write one more step. Do I have any extra space? Oh, I have a little bit of extra space here. Squeeze, squeeze, squeeze. What am I going to say here? So w minus 15 over 2 plus or minus square root of 117 over 4, which we know is square root of 117 divided by square root of 4. So I can say w minus 15 over 2 equals square root of 117 divided by 2 plus or minus. And now I can kind of split that up into 2 as usual, as I usually do. So w equals positive square root 117 over 2 plus 15 over 2. If I move this to the other side. And it also equals negative root 117 over 2 minus 15, plus 15 over 2. And now let's find these two answers. What is square root of 117? Is in fact, I can actually simplify that. It turns out that's 3 root 13, or 117 is 9 times 13. So, but it's one decimal place, so I'm gonna have to do that, solve that anyway. So that's 10.81 as it turns out. So let's look at these two answers. I have 10.81 plus 15 divided by 2. So this w, if you calculate it, equals 12.908 32691, or it equals negative root 117 plus 15 divided by 2, which is 2.09, or 091673087. And so we have two answers, so we're going to finish the question. Just kidding. If we look at this question again, let's see if this answer actually makes sense. If the width of this border equals 12.9, this diagram implodes because this entire length is 12, and now we're saying that this one width is 12.9, which kind of makes no sense, right? It will completely break the area of our small rectangle, and that value just doesn't make sense in terms of the question. So we'll say rejected, as realistically w has to be lesser than 6 if you think about it, because if w equals 6, then the width of the smaller rectangle equals 0. And technically that is possible, but it wouldn't really make sense in terms of a garden. So it has to be less than 6. Realistically, you can just say rejected. You don't really have to give your reason. So this is the correct value of w. So we can say w equals 2.1 meters, rounded to one decimal place as our final answer. Therefore, blah, 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 dot, dot, dot. The width of the tulip border should be 2.1 meters. That is the answer there. Okay, so that was an interesting question. Again, it's hopefully we see where we kind of got the expression. Once we get the idea behind all the practice we did all the practice that hopefully you did when we did worksheet 3.6, that is all has been posted, is the idea that we should be very, very comfortable solving for x or solving for w by completing the square method. And the only extra step we're doing here is really coming up with this equation. And once we know, there's only like a select number of types, word problem types. And once you know all those types, after that is just completing the square. And hopefully we're okay with that and we're not struggling with that. so we can, solve this question. So let's look at example 3. Example 3 is a very, very star, triple star, quadruple star. This is like the like favorite exam question. You will 100% see one of these questions in one of your tests, assignments, or culminating or exam. Again, you probably would have if you still had any of those at this point. We're not sure whether we will. So, fingers crossed we'll have some kind of we will have some kind of assessment. It's just a matter of when and how. So, we'll wait and see. But again, we're gonna learn how to do this kind of question. We've actually done some of these questions, are very similar questions in the homework that was assigned before. As part of like just look over. I think I've done some of those questions, but we will do it again as part of this lesson. So, okay, let's see here. Flight of a bowling ball is modeled by this equation. So, part A, how long will the bowling ball be in the air? Part B, what is the maximum height of the ball? Part C, what is the height of the ball when released? Usually these questions follow the same format of like A, B, and C, asking the same 3 questions. Always answer part C first, or realistically this question, what is the height of the ball when it is released? That is like the easiest question to answer, because realistically, what is that asking you? It's asking you for what is h of 0. That's what it's asking you. It's asking you, okay, when time equals 0, as soon as the ball was released, at t equals 0, what is the height? So we can find that super easily by putting in h of 0, which is 0 plus 0 plus 15 equals 15 meters. Or meters? Sure. We're going to say it's 18 meters. So we're going to say it's meters. And we'll see here that that's where the ball started to be released. And now, like, this ball is going to presumably do something of a, like, if you picture bowling, you're going to like toss it up in the air a little bit. We don't really know what this maximum height is, question mark still, and we don't really know when it's going to fall on the ground. That's also a question mark. I just arbitrarily drew some values here. So what we do know that it's going to be a parabola. What we do know so far is that it starts at 15. That's the only realistic thing we know. And we have to find, okay, how long will it be in the air? What's the maximum height, etc., etc. So, okay, let's try and do that. So first, we'll try and answer the question, what is the maximum height of the ball? Because that's kind of straightforward. We know how to do this. That is basically, we're asked to find the vertex. And finding the vertex we know is easy because we have a special method of doing it by way of we're gonna do, even though I think on the answer key I believe we've done completing the square, I'm gonna go ahead and do partial factoring in order to do that. So if you look at negative 5t squared plus 10t plus 15, that's the equation of our parabola, is equal to h of t or y or whatever you want. And now I'm going to do partial factoring, so negative 5t, that becomes t minus 2 plus 15 equals h of t. So realistically, the two symmetrical points are 0, 15, which I kind of already knew, and 2, 15. So if I look at this carefully, if I look at this graph carefully, I can put another point, 2, 15, as a symmetrical point. I know this is a downward facing parabola, so we'll have a maximum because of the a value is negative. So again, I'm looking at something that does like this kind of thing. And these two are symmetrical points. So my axis of symmetry, of course, is x equals to 1, which I did 0 plus 2 divided by 2, which I got 1. And now my vertex is, I just put the 1 into any one equation. I'm going to put it in this one. So h of 1. So when I say t equals 1, not x equals 1, I mean t equals 1, of course. H of 1 equals negative 5 times 1 times 1 minus 2 plus 15, which is negative 5 times 1 to positive 5 plus 15, which is in fact 20. So I kind of overdrew this a bit. So we know the vertex is at 120. So again, whenever we're given context, we'll kind of translate that. That means the ball reaches a maximum height of 20 meters at 1 second. So at 1 second, we know this ball is going to reach a maximum height of 20. So that is the trajectory of this ball, and if we kind of extrapolate, we know it's going to land somewhere over here, but we still don't know exactly where. So that's what we're going to find in our final question. How long will the bowling ball be in the air? We're looking essentially for when it's going to fall to the ground, right? And the time from when we start, which is t equals 0, to when we fall on the ground, that is going to be how long the bowling ball is in the air. So in order to solve for our t value, we are of course going to use the completing the square method. So negative 5t squared plus 10t plus 15 equals 0. I set h of t to equal 0, right? Because I'm solving for the 0 or the root where the height equals 0. It's on the ground. And now I will, of course, proceed to use my completing the square method. Factor out a negative 5, t minus 2. Actually, I'm just wondering if I can solve this in an easier method. This looks solvable. And before I start, I mean, you could just use completing the square. I am just going to try and see t squared minus 2t plus 3. I think this is factorable. Negative 5, and I think it like two numbers that multiply to 3 and add to negative 2 is negative 3 and 1. So t minus 3 times t plus 1 equals 0. And so t here equals 3 seconds, or t equals negative 1 seconds. Again, I would use this method if it's a multiple choice question or something like that. You could use this method and come clean without. Just because if it is a lot of marks, I would double check whether Mr. Tremoli expects you to do completing the square method. Because sometimes it will be mentioned as part of the question, like use complete the square method or something like that, in which case you have to use that method. So here you don't really need to, but if you did, it wouldn't necessarily be too hard. For example, negative 5, you would get t squared minus 2t, and I'd move 15 to the other side. Divide by negative 5, divide by negative 5, t squared minus 2t equals negative 3. Here, of course, I would find the magic number. Doing negative 2 divided by 2 is negative 1. Square that equals positive 1. So I get t squared minus 2t plus 1 minus 1 equals negative 3. Group the first three terms. That's t minus 1 squared equals add the 1 here, negative 2. So, no, that's not right. Oh, this is a plus 3. Positive 4, there we go. Take square root of both sides. T minus 1 equals plus or minus 2. And here we get t equals plus 2 plus 1 is 3. T equals minus 2 plus 1, negative 1. Same answer. Obviously, this was a bit more work, but if you have to show your work, it's always good to. We'll do completing the square method. There we go. Now that we have our answers, t equals negative 1. Obviously, we reject because we don't really have negative time. Time not lesser than. Oh, time has to be greater than or equal to 0. That's our restriction given the. What we call restriction given context, because the x is time, time's on the x-axis, time has to be greater than or equal to 0, so time equals 3 seconds, so the ball is in the air for 3 seconds, and 3, it's going to land over here, not over there. Scratch, scratch, scratch. So that's how we solve this question. This is going to be an interesting question. For how long correct to 2 decimal places will the bowling ball be at a height greater than 18 meters? So what are we doing here? So if we look at where 18 is, let's say this is 18. When we draw a dotted line, you see, like at this point in time, the ball is higher than 18, and at this point in time, the ball drops below 18. So we're really looking for how long was this interval of time, because if you draw a line from 18, this is where the ball just crosses 18, and this is where the ball just drops below 18. So we're trying to figure out, okay, how long was this time interval? And so for that, we have to find the two values over here. Basically, how long was the ball above 18 meters in height? So here, we're going to kind of adopt a very similar method. We've already done this. So instead of finding the roots or where height equals 0, so the previous question we saw, okay, we found where the height is going to equal 0. In this question, we're going to say, okay, I still have h of t equals negative 5t squared plus 10t plus 15. But I'm going to say h of t now is equal to 18. So we're going to set h of t to 18 because that's what I want my height to be. I want my height to be 18. So I got to figure out, okay, what two values of time? So what value of time here, question mark, is my height equal to 18? What value of time here, question mark, is my height equal to 18? And if I subtract those two times, I will get how long the ball was above 18 meters. So I'm trying to find the time where it just crossed 18 and the time where it just fell below 18, kind of. And so if I get those two times, I can essentially solve this question. And that's the idea behind what I'm trying to do here. So I'm going to set 18, and this is, again, old school, easy peasy stuff. Subtract 15, subtract 15. I'm just going to move this to the other side for, I still have equals to 3. And here we'll see we can't really common factor and do this the easier way. We do have to do completing the square, which we will do gracefully. T squared minus 2t equals 3 divided by negative 5 divided by negative 5. T squared minus 2t equals negative 3 over 5. Negative on the numerator always. Magic number, negative 2 divided by 2 is negative 1. Squared is 1, so I'm going to add and subtract 1. T squared minus 2t plus 1 minus 1 equals negative 3 over 5. I will group the first three terms, which becomes t minus 1 the whole squared equals negative 3 over 5 plus 1, because I moved this minus 1 over here. Take a common denominator. See, I'm not even writing the steps this time. It should be very... at this point, you should have done so much practice that this just becomes second nature, 2 over 5. Now that I have that, I take the square root of both sides, so I get t minus 1 equals root 2, square root of basically 2 over 5 plus or minus, and then I move the 1 to this side, so I get t equals 1 plus root 2 over 5, and t equals 1 minus square root of 2 over 5. And again, I probably should rationalize this. Ideally, root 2 over 5 is root 5 over root 5, because I want to get rid of the root 5 in the denominator. This is root 10 over 5. So this is what I'm going to write over here. Actually, does it really matter that we have to do this? Probably not, because we're asked to find this to 1 decimal place. And so, because of that, whichever way you do the calculation, before or after rationalizing it, won't really matter. But we will rationalize it, A, for practice, and B, just to maintain good form while doing these questions. So, okay, so we're going to do, okay, what is 1 plus, turn calculator on first, square root of 10 divided by 5 is equal to 1.6324555532 seconds, and 1 minus this answer, root 10 divided by 5 is equal to 0.367544468 seconds. And now basically what these two time intervals stand for is this, whatever this x value was or t value was, and whatever this t value was. So time, the ball was at a height greater than 18 meters, or greater than or equal to 18 meters, was, 1.6324, whatever, this number minus this number. So I'm going to do that, 1.6324555532 minus whatever the previous answer was, and we get 1.2649. I'm going to round to 2 decimal places, so this is our answer. 1.26 seconds. And hopefully all of us got that. We see what we did to get that. I understand this video has gone on for 36 minutes. That's quite a long time for this video. But again, we did cover 2 lessons technically. So we are going to take the time to look over some textbook questions. Page number 178. Am I on page 178? Of course I am. And we're going to do question 9, 13, 16, and 17. Okay, let's check these questions out. 9 to 13. I'm going to skip 14, 16, and 17. Okay, I'm not going to do all of them because that's going to take probably another 40 minutes. But I'm just going to get down to the equation. So hopefully we're okay with completing the square method to solve for x. I'm just going to show you how to get to the equation because that's realistically the hardest part. So rectangle, okay, this is fairly easy. Rectangle area has an area of 330. One side is 7 meters longer than the other. So let the sides of the rectangle be x and x plus 7, because if one side is x meters, the other side is x plus 7 meters. So again, area is, we know, is the length times the width, or multiply the two sides. So I get x times x plus 7 equals 330. So if I open this up, I get x squared plus 7x equals 330. I can just straight away proceed with completing the squared here. To find the magic number, 7 divided by 2 whole squared. So add and subtract 49 over 2. Group the first one, etc., etc. And you will solve this, hopefully. Sum of the squares of 2 consecutive integers. We already did this. X squared plus x plus 1, the whole squared equals 685. Sorry, excuse me. And we'll obviously have, if you remember, we solved this and we had 2 possibilities. We had both the positive integers and both the negative integers that worked out to give us this sum. And again, if I use a quick guess and check, I'd probably say, let me try like 18 and 19 is actually 685. So the integers would be 18 and 19 and negative 19 and negative 18. Those are all the possibilities. So that was a quick answer. But again, we will do completing the square and solve that fully. All right, question 11. A right triangle has a height 8 centimeters more than twice the length of the base. So, do I have extra space? No. Sigh. Oh, I took up all this extra space for all this stuff. Erasing this is going to be a pain. My computer lags a lot when I try to erase stuff for some reason. So, give me just a second. Actually, I'll pause the video and then we'll come back to it. And, ta-da! Now you know how like every magic trick on the internet is done, pretty much like video editing. So, like we said, we're gonna continue here. A right triangle has a height 8 centimeters more than twice the length of the base. So I'm gonna write small so I don't have to do that again. Let the base be x. So if we draw this triangle and say the base is x, the height was 8 centimeter more than twice the base. So 8 centimeters more than twice the base. The area is 96. So find what are the dimensions? Find x basically. And here we can say that, so find the dimensions. I mean, you don't really have to find the third side, you just have to find the first two sides. So we're just gonna get to it where we say half times the base times the height equals 96. What I would actually do is, well, I mean, you could do this multiple ways, but I would factor out an 8 plus 2x. I'd actually even write 2 and then x plus 4 over here, just because it looks nicer. So I have actually half times x times 2 times x plus 4 equals 96. I can cross out the 2 and 2. So in the end, I just get x squared plus 4x equals 96. And you can, this is actually a super easy completing the square because this is already a perfect square. We know if I add and subtract 4 here, so I get x plus 2 squared equals 100. If you are familiar, yeah, if you do that, you should get that, and then take the square root. X equals 8 and negative 12, of which you will obviously reject the negative 12. So x equals 8, and the other side equals 24. And if we do 8 times 24, we should get, divide by 2, we will get 96. So that's that answer. Easy peasy. And we can see here that question number 12 is very similar to our border questions, a thinking question, very good assignment question. Make note of that. Jackie mows a strip of uniform width around her 25 by 15 and leaves a patch of lawn that is 60% of the original area. So again, 25 by 15 in this case. So we'll come up with the equation again. So here we have a 25 by 15 lawn, and she mows a strip of width W here. This question is a little bit different because what this is saying is it's actually easier because she leaves a patch of lawn that is 60% of the original area. So let's say the original area was A. This patch of lawn that is left over, this is like the lawn, right? After she has finished mowing it, this is what's left. This is all still grassified or grass. And this is said to be 60% of the area, of the total area that was at the beginning. So we only have to find, okay, what are the dimensions of the small rectangle? We've done this kind of exercise before. The dimensions of the smaller rectangle are dimensions of leftover lawn, or the smaller rectangle is 25 minus 2w and 15 minus 2w. So what the question is saying, that this area, so the area of the leftover, which is 25 minus 2w, not that, times 15 minus 2w, that is the dimension, equals 60%, which I'm going to write as 60 over 100, times the original area, which was 25 times 15. So this is what that question is saying. So if we kind of expand this, 25 times 15 is 250 plus 125 is 375, minus 50w minus 30w is minus 80w, plus 4w squared equals 375 divided by 5 is 75 times 3 is 225, I think. And once we get this, we just rearrange so that everything's on. Realistically, actually, we know we have to complete the square, so we can actually move this 375 over to this side, and we get negative 150, and you know the rest. You factor out a 4, then divide by 4. So w squared minus 20w equals, what is this again? 20. Does 150 even divide by 4? I don't think so. That's unfortunate. Well, we can at least make it 75 over 2 and work from there, you know, to do the rest, completing the square, blah, 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 blah. Okay. A small flare is launched off the deck of the ship. The height of the flare above water is given by this. So again, we know that if we say t equals 0, we get h equals 9. So that's the height of the ship above the water in the first place. So this is ship, and this height is 9 meters. And we are launching it above the water, and it's going to and bloop into the water eventually. And we're asked to find when will the flare's height be 150 meters. So obviously this goes, if the ship is 9 meters, you're launching this flare more like this because it has to reach 150. So you're really launching it, you're shooting it straight up into the sky basically. And let's say that if we draw the y-axis like this is 150, what are we at? When will the flare's height be 150? So we have to find this time, question mark. And we will also get this time because at this point in time, the flare's height is also 150 meters. So we'll get kind of two values for the height. Give me 1 second. Awesome. Sorry. So basically we have to find these two values for our height, and we've done this question before. We say let h of t equals 150. We set that height to 150 basically, and we solve for our time. So our question will be 150 equals negative 4.9 t squared plus 92t plus 9. You know, bring the 9 over, complete the square. This completing the square is going to be a huge pain because it's like all weird and stuff. But I think actually this might not be bad. 9.2. What is 92 divided by 4.9? It's a decimal. Never mind. It's super bad. Here, again, if you're allowed to use quadratic formula in the question, I would highly recommend using quadratic formula. We haven't done a lot of work with quadratic formula, but hopefully you guys, I did like one question on it in lesson 3.5. You can take a look at that and see how that went if you have any questions. But hopefully we remember that from grade 10 realistically. And part B is also very straightforward. How long will the flare's height be above 150 meters? Is once we find those two times, you just subtract those values and you get the answer. Okay. Again, 3 possible ways. You could probably factor this and do like regular factorization. You could complete the square method. You could use quadratic formula. That would probably be 3 different ways you could do that. So here, I'm going to talk about this question, even though it wasn't assigned in the homework. This is an interesting question. So if we look at this again, we might have seen this in grade 10. If not, this is kind of confusing to get your head wrapped around, so I will go over this. A bus company has 4,000 passengers daily, each paying a fare of $2. For each increase by this much amount, the company estimates that it will lose 40 passengers per day, because that many people aren't willing to, pay an extra $1. They're like pissed off or fed up or whatever. So the company needs to take in this amount of money per day to stay in business. What fare should be charged? So you were given this amount of money. So how do you get that money? Basically $10,450, right, has to be equal to the amount of money that's taken in. So how much money is taken in? This is equal to the number of passengers that are traveling times the cost or the amount gained for one passenger. Is that, hopefully that this is like the key. If you know this step, it's kind of like you can solve any one of these questions. But the idea here is, again, okay, like if I'm at a hot dog stand and I'm selling hot dogs, the amount of money I get at the end of the day is like how many hot dogs I sold times the cost of one hot dog. So if I sold 10 hot dogs for $2 each, I get 10 times 2 is $20. So the same idea here. So here, the number of passengers, again, equals normally you would just say, okay, let the number of passengers equal 4,002. But, if the bus company only does that, it's only going to make 4,000 times 2, $8,000, which is not enough, really. We want $10,450. So it has to do some increases. So it has to raise the price by 15 cents. So let's check that out. So what happens if you raise the price by 15 cents? I lose 40 passengers, so I'm only going to get 3,960 passengers times $2.15. And you'll see here that I get 8,514, which is a bit more than 8,000. So I'm improving, but I need to know, okay, how many times am I going to increase this? Am I going to make it, $2.30, $2.45, $2.60? Like how many times am I going to increase the price? So let the number of price increases or price increments of, $15 price increments be X. So if I raise the price X number of times, my number of passengers is going to be from 4,000, I'm going to decrease by 40X, right? Because each time I raise it, I lose 40 passengers. So if I raise the price 5 times, I've lost 40 times 5, 200 passengers. But the price for one passenger is $2 plus 0.15x, because as you know, if I raise it once, I raise it by 0.15. If I raise it twice, I raise it by 0.3. So this is basically our equation, which you will then, expand. This is 8,000. I don't know what this is. 0.15 times 4,000. It says 600 minus 80 is plus 520x. And 40 times 0.15 is 6. So minus 6x squared. This equals 10,540. Rearrange and solve for x, and you will have an answer to what fare should be charged. I think we were going to do 16 and 17. I understand this video is getting horrifyingly long. My apologies. So this is, again, very easy. Perimeter of a right triangle is 60 centimeters. Interestingly, now that I think about it, I assumed a kind of right triangle over here, but this didn't have to be a right triangle, right? It could just be a regular triangle with x and a height. It didn't really have to be a right triangle, so it's important to check assumptions there. But here we are given that the perimeter is 60 centimeters. The length of the hypotenuse is 6 centimeters more than twice the length of one of the other sides. So let one of the other sides be x. The length of the hypotenuse is 2x plus 6, or 6 more than twice the length, and find the length of all 3 sides. And obviously, we realize that we have a gap in our knowledge here. We don't know this, but we do know that the total length, the perimeter rather, so x plus 2x plus 6 plus this third mystery side, let's call it y, equals to 60 centimeters. So I want to isolate for y. I get 3x plus 6 plus y equals 60. So y basically equals to 60 minus 3x minus 6, which is equal to 54 minus 3x. So instead of y, I'm going to write 54 minus 3x. Unfortunately, the pain has just begun, because now comes the really hard part. Because so far all this this was just to find a third side, because now we are going to use Pythagoras' theorem to come up with an equation for our third side. And so, as we can see here, Pythagoras' theorem to come up with an equation that can be solved for x, because that's the only kind of thing that we know for a right angle triangle. Again, I told you this erasing takes forever. It's very annoying. So we're going to kind of set this up as x squared plus 54 minus 3x the whole squared equals 2x plus 6 squared. Again, instead of doing this, I would actually probably factor out a 2 here and factor out a 3 here, which leaves me with 118 minus x. So instead of writing this, I'd write x squared plus 3 times 18 minus x squared equals 2 times x plus 3 squared, which in fact is going to kind of I can make this kind of, so this is 3 squared times 18 minus x. Okay, I don't know if this realistically makes it easier. You still have to do some like crazy expansion with this, multiply everything by 9, multiply everything by 4, bring everything to one side, and then do completing the square to solve for x. It's still insane, but at least you're not doing 54 squared. I mean, you will get the same answer whichever way you do it. You don't really have to. If this is confusing, don't do it. Just, expand. I mean, expand properly, please. Don't do 54 squared plus 9x squared. This is 54 minus 3x times 54 minus 3x, which is, 54 times 54 minus 54 times 3x, which is, I believe, 162. Minus another 162x, and that's minus 224x. No. 324x, and then plus 9x squared. Expand properly, and bring everything to one side, completing the square. So, find the zeros of this function. Again, hopefully this is not too bad because we're just going to take a common denominator here. X plus 1 minus 1 times x plus 1 plus 1 divided by x plus 1. And we're trying to find the zeros, so we set that equal to 0. The usual stuff, state restrictions, x not equal to -1. Very important. And then, do the expansion of all this, find a quadratic, multiply this to the other side, so that just goes away. And you're just left with the numerator is going to be equal to 0. Which in this case the numerator is 3x squared plus 3x minus x minus 1 plus 1, so that goes away. Realistically, just 3x squared plus 2x equals 0. So this is actually super easy because is it super easy to find x? I'm not even sure. Yeah. Because you just factor out an x and you have 3x plus 2 equals 0. So x equals 0 or x equals -2/3. Those are the zeros. And of course, x not equal to 1 has to be, x not equal to -1 has to be stated. But those are my two zeros. We'll not forget the easiest common factoring here that's possible. So yeah, that's that. That was the homework. Again, I will pause this video. I will stop this video before we reach the holy 1 hour mark. I understand it was a lot. I think maybe I should have broken it up into 2 videos, but too late for regrets. I'm not doing this all over again. So I will see you in the next lesson. Again, if you have any questions, feel free to post a comment below. And I will get back to you as soon as possible. And again, if you, at any point in time, if you have any feedback for me, like, the Friday before we left, I was going to ask for feedback just in terms of teaching. But we kind of had a conversation about that either way. But if you think that there's anything that you want to see in these videos, just let me know. Until next time, peace out. Until next time I talk to you.